and welcome to Oceans Explained. This is just a short video on how to calculate hanging ratio for gill nets and why it's important. So, hanging ratio is denoted by the letter E and is calculated as the length of the headline of the net, excluding any bare extensions. So this is just the part of the net that's actually attached to the rope, and not any of the extensions of the rope which might be used to attach the net to marker buoys, for example. And this value is divided by the length of the stretched mesh. So, to show this with an example, here we have 3 nets with the same mesh size and headline length but made of different materials and set up differently. So this first net is possibly made of less flexible material and, as you can see, does not stretch very far, resulting in a high hanging ratio of 0.7. This next net is much more flexible and can be stretched further, resulting in a hanging ratio of 0.5 and more rectangular shaped meshes. Lastly, this net can be stretched the most, giving a hanging ratio of 0.3. As you can see, the more a net is stretched horizontally, the more it contracts in the vertical dimension, meaning for lower hanging ratios you need more rows of meshes to achieve the same depth of fishing. So these examples show hanging ratio is basically a measure of the shape of the diamond mesh and how much tension is in the net. Nets with lower tension tend to catch more fish by tangling, and these fish are usually from larger length classes. This holds true for species such as bogue, perch, cod and tuna. However, the opposite was found for blue ling, where decreasing the hanging ratio from 0.6 to 0.4 actually increased the number of undersized fish being caught. This emphasises how the relationship between selectivity and hanging ratio depends on the target species and the fish behaviour. Therefore, it's important to find a sweet spot where the catching efficiency and the selectivity are balanced. For example, it was found a hanging ratio of 0.6 gave optimal catch per gill net of cod in northern Norway. It's also possible to have a hanging ratio of 0, as shown by this gill net here, where the net is not actually fastened to the head rope. This specific net is used to catch sole in the waters around the Gambia, mostly through fish becoming tangled in the net, the degree of which increases with reduced tension as we previously saw. However, this increase in tangling is also correlated with increased bycatch. To summarise, having a lower hanging ratio is correlated with catching more fish by entangling, which is usually associated with catching larger fish, and this is true for species such as tuna and cod, and therefore there's usually an overall higher catching efficiency. However, catching more fish by entangling is typically associated with catching more bycatch and lower species selectivity and lower size selectivity.